Good afternoon. My name is Pınar Akpınar. Actually, I'll be here helping to present the works of my students. Actually, I'll be presenting 2 works in a row, so I'll be occupying the stage a little bit longer than the normal participants. We are going to have 2 presentations which are actually related. The first part is more theoretical, a review, and then the other one will be very much applied, some experimental results that we are having on the issue. Actually, I'm a civil engineer. I'm not an environment engineer. I work on concrete. I love working on concrete, and today I'll be presenting basically concrete but disguised in environmental issues. So I'll be talking about construction and demolishing wastes. And then I'll be going towards concrete. So construction and demolishing waste, it's a wide terminology. We'll start with an overview on the topic. And then we'll get to concrete, basically, concrete wastes. So, about construction and demolishing wastes, the main reason we have construction and demolishing waste is human population in the world. The current world population is reported as 7.7 billion, and I was reading an article the other day. It was saying that it took us like over 200,000 years to get to 1.5 billion. But then in the last 200 years, the population has increased 6 billion in the last 2 centuries. So when you have this much of population increase, of course you have an increase in the construction demand as well, construction activities of all kinds. In the pictures, I'm also putting some pictures so that our students are maybe more interested in the presentations, hopefully. So you can see Tokyo, which is one of the most crowded cities on the right top, and New York, some streets of New York. So when you have a high density in population, of course, there will be many activities in construction sector as well. So more construction basically will mean more demolition processes as well, and more waste will be generated accordingly. So I'd like to give some brief information about the content of the construction and demolishing wastes. Constructions, types, and conventional materials that we use in constructions, of course, change from country to country. For example, in the United States, you can find constructions, houses made of timber, which we don't use here. And in the United Kingdom, you can find brick structures, brick masonry. And here, in this part of the world, we are mainly using concrete structures. And of course, constructions have lifetimes and materials have life cycles. They don't last forever. And potential reasons for demolishing could be completion of the designed lifetime of structures. I'm not a structure design specialist, but I know that the calculations are done based on some determined lifetimes. So when that lifetime is completed, some problems may appear in the structure. So we have to do some checks, and we might be doing some precautions. We might be taking some precautions for the problems that may arise. So we can also have some premature performance failures. Even though the designed lifetime is not completed, we can have some problems in the middle of the service life. And sometimes we might need to take down the structure. We can have always demands for more modern structures. So we can demolish the structures that we have and put a more modern looking high-rise building instead. And we can also have demands for constructions of other services. Instead of residential, you might need factories or schools, other purposes. And of course, you can have always needs for maintenance and renovations. In those cases, it is very common to, completely or partially demolish the structure, and there will be a waste that will be formed as a result of the demolishing activities. Okay, so before we get to concrete, of course, we needed to do some studies on the literature. Actually, before I continue, I would like to mention that the student that was doing this study with me is from Syria, and he was especially interested in demolished concrete wastes, actually because of the war that he was having in his country. Because of the war, lots of the buildings were demolished of the bombs and missiles, and he was hoping to be able to learn something with the master studies and go back to his country and serve for the reconstruction of the cities. And for us in Cyprus, that was also an interesting topic, since we are not very familiar with recycling or reusing these materials. So for us, is also something interested in Cyprus. So as a beginning, we wanted to understand what is going on in the literature, what kind of studies are there, what are the critical issues that we should be considering in our studies. So we have done this survey on the literature, and we have seen that there are numerous studies in the related literature to determine the type and quantities of C&D, which are construction and demolition wastes, produced by different countries. And the results of these studies are critical for the determination of the optimum waste disposal and management methods, considering both the environmental aspects and the economic aspects. So we have seen that the content of the studies are changing depending on the country, depending on their needs, depending on their conditions, and the results and how they handle the results, how they try to get to a solution, also was depending on the country's needs. So here we are seeing some waste that are basically disposed without any control to the nature. I am sad to say that these two photos are from Nicosia, not very far from where we are. Unfortunately, in Cyprus, we don't really manage the wastes very well. So this is not very far from Nicosia city center. On the left side, on my left, we are seeing a mixture of the waste, which includes plastics, concretes, broken concrete, tiles, I can see. On the right side, it's mainly broken concrete pieces and asphalt pavements, I think. So as you can see in Cyprus too, we need some more awareness, and maybe we can start doing something about our construction and demolishing wastes. So in this study, we tried to survey recently published, I mean like last 15 years, over 50 research work, in order to provide understanding on the critical issues regarding construction and demolishing wastes, such as their characteristics, their impacts on environment, common waste disposal and management methods. Of course, as civil engineers, we are trying to also be a little bit practical too. In our region, we are using lots of concrete, so we wanted to have a closer look on the demolished concrete wastes, because as I mentioned, construction and demolition waste can contain a lot of stuff, and for us the most interesting part was concrete, so we will have a separate section on concrete waste as well, and we will be overviewing also feasibility of using these concrete waste as recycled concrete aggregates. There's a term, recycled concrete aggregate. I'll be talking about it, what it means and how we use it. So we were hoping to provide an overview to developing countries like North Cyprus that are intending to better manage construction and demolishing waste with the study that we have carried out. So, first thing, as I was mentioning, first step is always understanding the waste that we have. First finding that we got was you don't have much data about every country. For some countries you have more systematically reported data, but some countries are not maybe doing the study systematically, or perhaps they're doing it but they're not reporting it. So we were able to find some European data. These data covers the annual construction and demolishing waste quantities generated by European countries. That covers the waste quantities for the year 2016. And we had some curiosity. While we were studying, we wanted to take this data and we wanted to plot it according to the years which these European countries were involved to Europe. That was just out of curiosity. So the years that you're seeing next to the countries, maybe they're too small, I don't know, starting from 50s to year 2013, these are the inclusion years of the countries to the European Union. I mean, broadly speaking, we see that the countries that were involved in the EU were generating more waste. Okay, maybe that is a coincidence. Maybe it has nothing to do with the year of inclusion. However, maybe there is some kind of relation as well, because we believe that these countries like UK or Germany, which are generating a lot of waste, they have some kind of economical growth because of EU. Because they were in the European Union, they were the strongest countries in the European Union, in the golden ages of the European Union. So maybe their economical growth is reflected to their construction activities. Of course, we don't have any scientific evidence, but we are just having some hypothesis on it. And we are also aware of the fact that this is not only about the economical level, it also depends on the population of the country, very much. So we don't have the population. Yes.
What is the number?
Y-axis? Y-axis? Yes. The numbers are multiplied by 1,000 tons of waste generated per year. Per year. Yes.
So it's tons of multiplied by
yes.
Tons of year, tons of waste.
Yes, generated per year for the year of 2016 numbers. 2016. Okay. So the other factors beside the economical level are the population for sure, and the demands of the construction activities, and it also depends, the amount of waste will of course depend on the level of awareness on environment and investments that are done in that category. So, but we are seeing, the main thing that we were able to see from these inspections is that first thing is of course knowing the quantity and the type of waste that the country is producing. So,
which one is the
yes.
To which country does it belong to?
Highest one is France.
France.
Yes, yes sir, France, then Germany. So somehow they are really generating high amount of annual construction and demolition waste. Yes. Yes. So the big countries are somehow, is it the big because of the population or the economical level of the country? So we are not very much sure of that fact. Okay, next thing that we wanted to learn ourselves was that, okay, so what is the hazard, what is the damage caused by this construction and demolishing waste? Then we were able to find something else in the literature. The fact that the hazard that is caused by the construction and demolishing waste is reported as a general hazard or general materials causing the hazard as a result of a mixture of construction and demolishing waste. So all of the studies that we encountered, not all but almost all of them, are reporting a mixture of plastic and then metals and concrete and broken bricks and glasses. So it's always a mixture. They're always doing studies or reporting studies on their cases, which involves a mixture of different types of construction and demolishing wastes. And we were able to see that there are many potentially hazardous materials that are released from these construction and demolishing waste, which included arsenic, lead, cadmium, chromium, copper, mercury, nickel, zinc, phenol, sulfate, fluoride, chloride, magnesium, calcium, a lot of them. And second thing that we have noticed in the literature is that since majority of the studies are reporting a mixture, they're studying on a mixture of construction and demolishing wastes, we are not very sure which material is caused by which waste type. So it wasn't clearly reported. Of course, when we made some investigations, we were able to see potential origins. For example, some of these materials are used in the paints, so it's not the element, the construction element that has the material. However, the painting that they applied on it or the sealing materials that are applied on them might have these potential hazardous chemicals. But there was no systematical study reporting each construction materials waste causing these elements. That was another thing that we have noticed in the literature. So a lack of detailed information on the individual leachate results for each type of waste and the impact, exact impact of that type of waste only on the environment was not very systematically reported in the literature. We have also seen that regulations there are some regulations. Some international associations have announced some concentration limits for these materials that are potentially hazardous. So at least there are some studies indicating the safe limits or dangerous limits for these materials. I believe that as it is in Cyprus, it's in many countries as well, that concrete is somehow a popular material. So we were able to find few more studies that were concentrating only on the effects of concrete wastes individually, apart from the mixtures that I have commented before. And the hazards, potential hazards that we are expecting from concrete waste is that it basically reported to lead the release of various materials like chloride, sulfate, and mainly calcium hydroxide to soil. And calcium hydroxide yields high alkalinity. So when you have more calcium hydroxide leaching to soil or the groundwater, the pH was rising, and which has a negative effect on the vegetation, on the soil and the groundwater quality. And of course, if vegetation is affected, animal existence is also affected to an extent.
So 2 minutes to conclude.
Sorry?
2 minutes.
Yeah, oh my God, okay, I'm getting faster than, sorry. So calcium hydroxide leachate also affects the groundwater as well. So I'm going to be fast with the warning, thank you. So most commonly used waste management methods that we have seen in the literature was landfilling, incineration, and recycling, of course. So shortly, landfilling with some image is shown. It is considered as the simplest, but it is not necessarily the most efficient method. What you do is you excavate the location, and then you put the waste, and then you compact it, and then you cover it with soil, and you compact again. Of course, you have to have some system to release the gas that may come out. It is preferred because seemingly the waste disappears. However, it is there, and its negative impacts are not fully eliminated. So it has its good sides and bad sides. And going fast, incineration is also considered as a good method for handling waste, but of course it is applied to type of waste that can be burned. So for example, some construction and demolishing waste cannot be burned, like concrete. What do you do with it? You cannot really burn it. If you're talking about plastic or timber, probably you can handle it with incineration, but you cannot handle concrete or bricks with burning. It is an advantageous method because it really reduces the volume of the waste if it is burnable, combustible. And in case if the facility is well equipped, you can have some also energy production out of these facilities as well. Recycling is of course accepted as the safest method, the most environmental friendly method. I'm gonna, from this point on, I will be focusing on the concrete waste recycling, which is called, what we call it, recycled concrete aggregates. So, summarizing it very quickly, is that when you have a demolished concrete structure, of course you have big columns or beams, big elements, you just crush them into smaller sizes, and they become like stone particles themselves. But these particles do include real gravels inside and old concrete surrounding the aggregate, original aggregate. So as all of it, we take it as an aggregate, as a gravel itself, and we use it in the manufacture of new concrete. In concrete, conventional concrete has cement, water, and gravels and sand inside. So we take the natural gravels out and we replace it with the demolished concrete parts. So these demolished concrete pieces are called recycled concrete aggregates. In this way, we are making our structures as normal, looking normal, and then we are eliminating the waste that could be thrown to the environment. So we are eliminating those. Oh, here we have a photo. You can see that on the right side there is a darker area in the middle. That darker area is the original gravel that we had in the old structure. And then the light gray part around it is the old concrete, old mortar covering the aggregate. So we use it as a stone piece itself, the gravel itself, we add it to new concrete. Of course, there are some problems with it, because if we want to eliminate our concrete waste in this way, we have to make sure that the new concrete that we are producing have a good quality. If the new concrete that we are producing with the inclusion of the waste is not good quality, nobody will want to use that new concrete. So, and the problem is that the old broken concrete parts do have bad quality, do have low performance. That's why the building was demolished in the first place. So we have to be sure if that bad quality old concrete in the waste is giving any negative effect on concrete, on the new concrete or not. So we also made some literature survey to see what other people are doing. We have found out that there are, of course, several studies considering the use of these recycled concrete aggregates, and we just summarize all the information that we have found in 2 tables. We thought it was more practical. So we are checking the characteristics of new concretes that are made with the inclusion of recycled concrete aggregates. We have seen that yes, we have seen that the general quality is reduced when you're putting the waste. So compressive strength, split tensile strength, modulus, workability, these are all sought after properties of new concrete, and they're always worsened with the inclusion of the waste, which is not good news. Again, for the long-term durability of these new structures, we are also seeing worsened qualities, unfortunately, when we are including the waste in it. So when you look at these 2 tables, the view is not really good. So when we put the waste in our concrete, it looks like a good solution, but then the quality of concrete drops drastically. However, of course, engineers are here for finding solutions to the problem. So we also made other studies about researchers who are seeking after the same thing. Let's put the waste in the concrete, but let's find another way to improve the quality. So we have seen that there are several studies who were arranging the contents of the concrete, including the waste in it, but then changing other parameters to get a high strength value, which is what we are looking for. And we were able to see that it is possible. And in fact, in the second presentation, that is also mine, so I'm just stealing my own time, actually. We will be showing you how to do it, how to produce concrete with the wastes, but then still having an acceptable quality level. Basically, summarizing all I have said is that first thing is understanding the country's situation, which is how much waste you have, what is the type of the waste you have. If you don't know these 2, you cannot really find the optimum waste management method. This is very important. And landfilling is observed to be a popular method, but we know that you cannot eliminate all of the hazardous effects of the waste with landfilling. And then we are seeing that there are some lacks in the literature. People are not reporting individual effects of individual construction materials individually, separately. That we couldn't find a systematic study on that. And lastly, we are seeing that concrete is somehow more studied in the literature, and it mainly affects the soil and ground quality because of the increased pH, and recycling could be a potential way to eliminate concrete waste. How do we recycle it? By adding the demolished concrete waste into new concretes. And there are ways to enhance the quality of the new concrete, even though the waste that we are including in is dropping the quality. Thank you very much. This is the first study. And then the next one. Maybe they will be asking questions. Okay. So you might have some questions for the first part, and then we'll have the applied part, second part. Yes. Yes, sir. Sorry?
How many parts do you have?
So in fact, there is a second paper done by Hiba Al-Attar, which is a student, I guess,
Yes.
of
Yes.
Madam
So
Pınar Akpınar.
my 2 presentations
So-
are in a row, Hocam.
So I suggest
Exactly.
that we will take 2 questions, and
Okay, sure.
maybe as Hiba Al-Attar is not here,
Yes,
and as
exactly.
the subject is related to the
Very
first
related,
presentation,
yes.
is maybe to talk about it
Exactly.
during the coffee break.
Sure, sure.
That's okay
Exactly.
for you? Okay.
Sure.
So
Yes, sir.
do you have any question, please?
Well, I think that all the papers that I've listened, I would congratulate you on the ease of your presentation.
Thank
That
you.
was excellent.
Thank you, sir.
And some practical questions then.
Sure.
First, do you want to combine
Yes.
construction waste with demolition waste? Because they are two separate entities. They don't have the same characteristics.
Sir,
So would you, I mean, in your management strategy, would you be inclined in using the same strategy for construction waste and
demolishing waste.
or
I see your point, which is a very good point. This is the first time I'm hearing that point, and I really, I'm happy to hear it.
I would not.
Yeah, actually, the terminology is C&D, construction and demolition waste, all everywhere. However, I see your point, but then I would like to argue a little bit, because when you're doing a construction, the waste that you have is mainly about the remainings of the materials that you are using, the unused parts or broken parts, but still the same construction material. Then when you construct the building and you demolish it, you have them broken, demolished construction materials again. So they're not very far from each other. Are they? Which sense do you think, sir?
I would think,
For example?
that they would be very much different, because you don't demolish things like bathtubs or pipes or anything. Whatever that remains from a construction site would be different. I suspect,
Yeah,
in the
tiles
way
and
that
ceramics
you
and this
can
kind.
deal with it.
Yeah.
I mean, so I would, since this is the community
Yes.
where the demolish waste
Yeah.
and demolition waste is much lower than the construction waste.
Yes.
Because there's a lot of construction going on.
Yeah,
So
but
the solution would be different.
however,
Any experience between the characteristics of the two categories?
so I understand. However, I don't agree 100%, to be honest, because when you're saying construction, I think it is easier for us to see the amount of constructions that are higher. But for sure, when you are demolishing an entire building, the total amount of waste that you have is also a lot.
About the magnitude, but not the characteristics. of it.
Characteristics are not very far either, Hocam. Is it? Because like when I think about the construction waste, I think about the materials that were not totally used. So they're wastes. Maybe you didn't use the whole part of the concrete, or you didn't use all of your bricks. Some of them were broken, so they're your waste during construction. And then when you demolish a structure, you have your crushed, demolished concrete and mortar parts, and then tiles again, because they're all taken down. So,
Well, I'm not going to discuss that. In the-
but I would like to discuss it in the break time.
I
So
suspect that they are very much different.
I'll be looking into that, sir, and then I will be happy to discuss it in the coffee break further with you.
Right.
Thank you.
This university is about to propose a management strategy for construction waste and also demolition.
Okay, then I'll be very much interested in learning more about that, sir. Thank you. Thank you.
We'll be happy to include you in this.
I would be honored. I would be honored, yes.
Thank you very much. Thank you very much for this very important talk for Cyprus and for the neighboring countries around it. And now we will move to the presentation, to the next presentation
So we're skipping
on.
all of it?
Yes, yes. We will talk maybe because
I see.
There's no
but-
time.
Okay, then
Yeah,
I will
this
not
is
be
what
able
Sasha said.
I will not be able to deliver the experimental part, which I think is very interesting. But then if you don't have time, I can.
if you can show the results, maybe to go straight to the
I can
results.
just summarize it maybe in 5
Okay,
minutes.
okay.
So.
But in
uh,
3 minutes, because
okay.
else we
Okay.
cannot finish at
Sure, sorry. So we are having some delays. I'll try to recover. So in the first part, we have mentioned about the importance of the demolishing and construction demolishing waste, which we could separately handle, perhaps. So, and what we did in the second study was experimental. What we did was finding something missing in the literature, missing in our opinion, which is majority of the studies working on recycled concrete aggregates are producing the recycled concrete aggregates themselves in the laboratory. So they're not old concrete, they're new concrete, just for experimental purposes. but they weren't really using old concretes from like real cases, which we thought that it's not reflecting the reality. And then we also saw that maybe they're using not just concrete, but a mixture, glass, brick, concrete, plastic all together. And we wanted to see only effect of old concrete. And also they were including up to a content, maybe 30% waste, 40% waste, but they didn't try to go up to 100%. So we wanted to do something which would consider these three missing parts. What we did was, let me very fastly find, so we were very lucky, in an ironic way, to find a public school building 25 years old, which had premature failure. It was observed to have cracks, and this is in Nicosia, it's a 5 minutes distance to our campus. It was having crackings and spallings, so it was reported to be, failing. So authorities just knocked it down, demolished it. We were so happy to take the concrete parts to our laboratory and use it as recycled concrete aggregates in our studies. So we were covering the old concrete, failed concrete part, and we were able to eliminate other bricks and glasses, and we were concentrating only on the concrete part, and we tried to make concrete up to 100% replacement of the natural gravels with these broken concrete pieces. So we had basically 5 mixtures, systematically increased waste. So these are replacement to the gravel, natural aggregates that we normally have in concrete. We have a 0 control set, all natural gravel, then replace 25% of it with the waste, 50, 75, and 100%, all of the natural gravel out and waste in. And in this way, the numbers on the right column are the amount of waste that we are eliminating. So for 1 meter cube concrete that we made, we were able to eliminate 0.7 meter cube of waste from nature. So in 1 meter cube, 0.7 meter cube waste, which was something considerable for us. We were happy. And then we made a lot of tests to see fresh concrete and hardened concrete results. And since we know from the literature that it is tricky to use the wastes, we add some additive materials and admixture materials, and we were able to get better quality for compressive strength, acceptable, like 45 megapascals, which is commonly accepted strength value for our structures that we are using now. And for also flexural strength as well, we were obtaining very good results that are like the conventional concrete without the waste inclusion. The only thing that we have seen is that we need to add more water to make it flow easily, because the old mortar was flowing. Thank you very much. Sorry for taking so much time.